Good afternoon, everyone, to our third part of our 5-part webinar series about QMULUS. Today we will talk about data analysis and insights. And for starters, at first, as always, a couple of rules or information. So everyone is on listen only, so you're all muted. If you have got any questions, feel free to send us these questions during the webinar in the Q&A option or directly in the chat, and then we will try to answer as many questions as possible by the end of the meeting. Now we will introduce ourselves as always, and we're gonna start with Frank.
Hi, everyone. My name is Frank Pietrakupa. I'm an engineer here in Montreal, Canada, Nitrix Metal. I've been here for a while. I started my career with Nitrix on the hands-on level, so design, project management, installations, startups, commissioning, and I'm doing even today a lot of customer support. Eventually I moved on to UPC, so I know my carburizers and I know my protherms. And now I'm back with Nitrix, working on the QMULUS team, and excited to be with this team.
Okay, next up, we're gonna have Mike.
Hello, everyone. Thanks for joining the meeting. You might already know me from the last webinars. I'm Mike Löbke, responsible at Nitrix Group for software and digitalization. I'm being part of Nitrix Group for 4 years. I'm not sure, maybe it's already 5. I cannot remember. It's been a while now, and I'm really excited about showing you the latest developments in QMULUS and what we can achieve with the apps we are going to present you today.
Then we also want to introduce Kurt Wilms. He's Director of Sales in the Americas for UPC Marathon. He has a lot of years experience in heat treatment and also with all about UPC products. He's the guy to talk to about QMULUS in sales for all the Americas. So if you have got any questions, feel free to contact him. Lastly, myself, Dani Ganczorek. I'm at UPC for 1 year now already. I'm mainly responsible in sales for software in Europe. So everything regarding software and mainly QMULUS, that's coming to me. So for everyone from Europe, just contact me if you want to have a separate presentation, if you need some information, a quote or whatever, just contact me. So where we are at in our 5-part series, as we said, we are at the third of the 5 webinars, data analysis and insights. Next year, we will have 2 more webinars, which will be asset and process management in January and advanced tech in February. So what are we going to do today? We will have a case study on the investigation of quality results, then a second case study about statistics of consumables and other product and production KPIs. We will close off with the apps in Spotlight, which we showed you by then, and with a Q&A. Please be aware that all of the data that we show you are manipulated data for demonstration purposes and do not represent any actual customer data as always. So we will start with our case study investigation of quality results. Mike, you want to take over?
Yeah, sure. So if you have been part of the last month's webinar where we talked about how to do audit audits, certifications, and quality assessment. You already know this illustration. For those who have not been part of it, just let me briefly explain it. So everything starts with the process itself. We are producing some products, some goods we are going to ship to our customers. But before we can ship them, we need to do the quality assessment and to audit also as well the processes. All the results, wherever they can come from, are coming together at a quality manager, and the quality manager then decides, okay, this part is good, this part is not good. For the case that the part is good, we are not going to discuss it today. Let's look on the case that the part is not good and ask ourselves why it is not good. So first, I think I would like to start with is maybe we can just check what is not good. So just as a disclaimer, as a note for you, for the audience here. So we decided to put ourselves into the shoes of a process engineer who has the task to investigate why certain quality results are not meeting the expectations. For this, we just found out a recent job. This is job number 7965, which run on a certain recipe. You can read it here. And we are going to investigate all things which are related to that job and find out if there's something wrong, if there's something we can make better, if there's something we should be worried about. First step, as said, we are going to investigate the reports themselves, and then we would like to check where we are in the quality statistics. So is this job maybe way off? Is this job okay-ish? Is there a drift in the quality? Is it just an outlier? So we will investigate that directly in the live system of QMULUS, and Frank will will just lead us through.
Okay, I am sharing my screen. Share. Okay. So I am on I'm on the dev, and I'm going to go to my audit. So I have I've been told that, hey, job 7396, the customer wants to see, has some questions or something. So before I call, I want to make sure I know my story. So I go into my audit and quality, and I'm going to take a look at, okay, how was temperature? And then this was already done. I know this is my job, 7965. I pick it, and I have here now, I know that it was 7965, recipe XYZ. My main thermocouple had a set point of 560, -5, +5 as my tolerance, 9 hours, 30 minutes, ±5 minutes. And actually it ran for 9 hours and 28 minutes. It passed, everything was in band, one clean entry, one clean exit, and everything is okay as far as temperature is concerned. So, okay, at the time, whoever audited this said it was good. So let's go back. Let's take a look now at any metallurgy that may have been included in this job, right? So I find this metallurgical report, right? So it's my, sorry, I'm back at, I clicked the same thing. I have to go to quality, and in my quality report shows here, I did a quality report back in the day, and I have a sample which ran inside this 7965, and the results obtained were a measurement of 380 microns, but I had to have been greater than 330. I had a white layer, which should have been between 18 and 22 microns, but I had 23. And a surface hardness, which had to have been greater or equal to 530, and I had 630. Now, this one is a little off. This is a failure, technically, and QMULUS originally said it was a failure. Someone overwritten it and okayed it with the customer, but also understand that 23 microns is hard to read. This is most likely a number which is an average of 5 measurements. So 23 was consider the average. But anyway, I'm not worried that the parts are bad at this point. So quality-wise, I say I can't see anything wrong so far.
Yeah, the only thing I would say we can see here is that the case depth and the surface hardness a bit too high. I would expect them to be a bit closer to what we would like to achieve, right?
Okay, they're higher than spec, but again, this quality report is fine, right? I can't say anything. So we need to go deeper, and I don't know, should we take a look at history?
Yeah, let's have a look if you can see something in the statistical distribution of the quality results for this particular recipe.
So let's go to our furnace, right? Michigan. Let's take 6 months and let's take a look at this white layer. So in the last 6 months, these are all the, and if a job ran and a quality report was done, then white layer was recorded. So this is all the white layers, but let's take a look at our particular job, CP249. This job, right? So these are all the jobs that were recorded in the last 6 months. And I guess this is my 7965. Yes, it is, load 7965. So it clearly looks out, and here's my Shewhart graph, and definitely it's outside of my 2 sigma. So interesting, it's deeper than the average, and it's deeper than, or thicker, sorry, than the previous jobs, and it's thicker than the following jobs. So let's take a look at K-Stat. If I look at K-Stat, again, for the last 6 months, I have this outlier at 393 microns instead of an average of 350 something, 360, right? So this is my average, and this is where this sample was. And let's look at surface hardness. Again, for CP249, this was 682 HV versus the average of 588, 590, 600, whatever, HV. So it's a little bit deeper, harder, more thick. Yes, it seems that way. Again, is it a metallurgical problem? I don't know. I don't think so.
No, I think this needs to be determined by the end user. So, but yeah, so at least the specs are okay. We fulfilled everything. Okay, white layer was a bit off. Okay, nothing to be worried about, to be honest. But let's maybe find out if there's a reason for that. Why is let's say, the thickness of the white layer, why is it thicker?
The weight is.
Yeah, exactly. And why is why it's harder? And let's maybe investigate certain other stuff. Maybe Daniel, you could just tell us, okay, what we could do next.
Okay, so what we could do next is having a look at the production logs. So what we could do, we could investigate, or we can investigate the process itself. So what process set points do we have? What readings? How did the recipe perform? And how were the individual steps of the recipe? Do we had any alarms coming up? Did we have any anomalies, observations? In general, is there something abnormal? Means we could have a look at our process first, and also then compare it to other processes with the same recipe afterwards to see if they look exactly the same, or if there is a difference between our process and the processes in the past.
Yeah, that's true. So this would be regarding processes. What comes to my mind, no surprise, is what about the machine? Maybe you can just go for the next page, because there's also the option to investigate the machinery itself and the controls. Maybe there's something suspicious, and maybe the alarms is giving us an idea of what might be wrong. So maybe, Frank, we can just investigate the process and the machinery with the 2 applications, production logs and alarm statistics.
Let me take over the screen. So we're back in our, share, sorry, I didn't click share. There we are. So we're back, this history and trends, and let's take a look and dive into this particular job. So by clicking here, I jump directly into the production log. I get to see now by default, I have here a temperature and I have here a KN and its set point. I see that my my interaction with the KN was not nice. I have these little bumps here. I don't like them, right? But not so bad. If I look at my KN, I have 3.5 instead of 3.07, 3.46 instead of 3.07, and not too worried, okay? Machine, I don't like the machine the way it behaves, but now let's do something. And I'd like to, from the observation point of view, I will learn a lot by comparing this with previous jobs. So specifically now I'll say, let's go take a look at this recipe, this one that ran now, and something very old, because, well, I assume no one complained and everything was good a long time ago. So let's take a look at and filter down our asset to M1 and accept M1 recipe CP24 something, 249, and let's look at the last year, and 7965. This is the recipe in question, but let's go back and choose these really old ones. So in the last year, there's the two oldest ones, and let's take 3 jobs in all and compare. All right, so temperature seems fine. So let's just close temperature, hide it, close temperature, hide it. And we are back at nitrating potential. So now I have here 3 nitrating potentials overlapped on the same graph. So let's start by zooming in. And, oh, I zoomed in too much, sorry. Let's start by zooming in. And I could see that my job, 7965, so the numbers in question are here. My job seems to be a higher KN than the other ones. Let's do a little bit of a statistical analysis, like for free. So let's go out and I will grab these markers, which help me close the QMULUS statistics. Okay, so if I just go with this part of the section right here, by analyzing this, I am going to show you, let me just zoom in a second. All right, by bringing in these markers, I now have marker 1, marker 2, and the important for me is min, the max in these markers, the average, and the standard deviation. So these 3 lines, I could see here that I have in my 7965, 3.82 is my average KN with 0.3 sigma versus 3.5 and 3.52 with a 0.26 or 0.08. So I can see that this job here was 3.5 average with extremely tight KN. It was constant, flat line. This was 3.5 with a little bit of a variation, all the way to 3.76. And this was 3.82 with a plus or minus 30. So it went up to 4.1, 4 point something with a max of 4.7 actually. So, okay, 7965 ran effectively with a higher KN than the other jobs. But again, I'm going to say, will the part really be affected with a 3.5 versus a 4.0 KN? I'm not so convinced. So I feel now let's take a look at the alarms that may have happened during this time. So if we jump out of here and let's analyze the furnace itself. So let's go to alarm statistics. In my alarm statistics, I want to jump straight to my furnace M1 and take a look at last 3 months. Search for all the alarms that are programmed for this furnace for the last 3 months. And I get to see a list here and the Pareto graph representation of all the alarms. Now, I will say that my biggest problem, 50% of the time, 46% of the time, was this furnace low pressure warning. for someone who's not aware, first of all, it's a warning, which means it's the pressure is suggested to be a little higher than this number. That's one. Two, deviation on my pressure transducer will easily give me this. So I'm not so worried I should actually exclude this or make my tolerance a little bigger. I think this is more of a nuisance that I should address than actual problem. This has nothing to do with metallurgy. I have one instance of a nitrogen high warning, but now what jumps out to me who would need to repair this, what jumps out to me is I have here 36 ammonia low warnings, 10 ammonia low alarms, 2 ammonia emergency, 1 a high warning, 3 ammonia low warning, 2 ammonia high warning. Like I have a whole bunch of ammonia stuff. I have some dissociation problems. I have a dissociated ammonia, and I have a whole bunch of analyzer pumps and analyzers and sampling. So if I look at all this, what I see is in the last 3 months, I should be looking at this equipment and realizing, hey, maybe I should be spend some time, take a look at ammonia mass flow controllers, ammonia filters. Well, I would check all the gas filters, all the solenoid valves, all the mass flow controllers, make sure all the lines are clean, make sure my gas pressures are okay, make sure my gas regulator on ammonia, let's say, could be starting to get damaged or dirty or something. Analyzer, I seem to have an issue here, so I need to take a look at that. Check my piping, check my cleanliness. So I would do all of this because I see that in the last 3 months, this is occupying a big chunk of my alarms, and this will lead to eventual serious metallurgical issues or quality issues. And I still have to say that I'm not convinced that job 70, whatever the job number was, 7396 or something, 7965, that job really had an issue because of this. However, yes, I would observe it.
Okay, thanks, Frank, for this elaboration. While Daniel is switching over to PowerPoint again, I would like to summarize what we currently have seen. So putting ourselves in the shoes of a process engineer, we can investigate with all the data inside of QMULUS with multiple applications, different things. We can identify visually already stuff. We have built-in statistics we can use, for example, with the production logs and so on. So this is really for the daily inspection. If you have something in particular which you would like to investigate, QMULUS is giving you all the tools at hand, no problem. We will talk about the automated anomaly detection in the webinar in February, by the way. So we have also some means inside of QMULUS to automatically detect abnormal behavior and also determine if there's something to be done, if we have to spend some time on maintenance, and if the process would be affected. So that said, I would like to hand over to Daniel to go for the next case study.
Yeah. Thanks, Mike. Thanks, Frank. So next topic will be the case study to statistics of consumables and other product or production KPIs. So obviously we know we have price and costs for our good parts, and we have a gross margin. If we want to increase the gross margin, obviously that would be also always a good thing. Then we probably would have an issue at the moment with increasing just the price. So first thing we could do is have a look at our costs. What kind of costs do we have? At first, we have all the machinery, which means depreciation, maintenance, building costs, tooling, lubricants, and so on. We have labor costs, which we will not tackle today. And then we have all of our consumption data. For example, what we are already measuring is electricity, processed gas, water, and a lot of other
consumables.
Other consumables. And for this example, we are at the moment not measuring cooling water and don't have no idea about the energy to cool down our water. But how we can get this information if they are not available? Can QMULUS do that somehow, Mike?
Yes. So the question is always, so we have a lot of information in QMULUS, but some things might be missing, and we would like to present you an option, a way to create information out of what we know. So let's assume we have Frank, for example, here. He knows that his M1, the Montreal, the nitrating furnace in Montreal, is running on 4 liters per minute, of 1 gallon roughly per minute of cooling water. And this cooling water, the valve is closed if we have for example,
Cold furnace, a
cold
cold
furnace, exactly, below 150 degrees Celsius, let's say that, and above 150 degrees Celsius is just open. And the idea is, how can we not create a so-called soft sensor? We call it in QMULUS a lambda sensor or lambda signal. Yeah, just to make use of this information to calculate the missing data. And Frank will show later on how to do that, but we would like to maybe first step into production statistics and yeah, let us check what is already available.
Yeah. Okay. So our goal here is to find out how much, what's the consumption of a furnace or a recipe or a plant. So if I start big and I just look at, I don't know, just December of all of Michigan, I have here many furnaces and I have here many headings, right? From ammonia to carbon dioxide to water at the end. But I can now see that a lot of gases exist here, but for example, there's no water for this other furnace, 2, 3, 4, whatever. They don't have these this water because the sensor does not exist. And we just created the sensor for Michigan M1. So if I were to drive deeper into M1, I can now see that in, well, let's go to a quarter which has a bit more data. I have ran this job once, but example, this job ran 13 times. And this particular recipe, I can find out, well, I'll give you an example. I have used 49 cubic meters of water for those 13 recipes. So if I divide, I find out that I use only 3.8 meters cubed of water for this particular recipe, but 3.27 for this one and 4.62 for this recipe. Okay, so this is, let's say, the interesting point. But what are these tables and how can I customize it? So first of all, I customize by select list, which is predetermined in QMULUS. So acetylene, for example, compressed air or argon, yeah, of course, our ammonia for our nitriders. But also take a look at this user-defined consumption, meaning 3, meaning 4, meaning 5, meaning, okay, so these are, I can define them at will. So if I make a sensor that will have a consumption of one of these filters every 10 cycles, then I can track that. So one of my KPIs will be this filter. And of course, I have here this water. So if I submit, I basically have told my report to include this acetylene, which we don't have, but yes, I have this water. Now let's talk about the water. And the water is just a symbolic representation of any other sensor that I can make. So if I go to production log, I don't necessarily need to go to production log, but what I want to do is I would like to see a chart, okay? Because it'll be easier for me to explain it to you. So let's just take, again, an example process in the last month and take whatever 19-hour process here. And we again hide everything except for temperature. That's what my recipe looked like. Now, if I were to create a new virtual signal, again, I want to show you my temperature. So let's just jump to it. There's my temperature main. And this is this reddish line. That's temperature main. For every variable, there is an associated ID, tag, nickname, whatever you want to call it. And QMULUS uses this variable, this number. This number represents this variable for this furnace. Now, on this graph, although you can't see it, I actually have two lines. I have thermocouple and I have this. So for example, here, if I do this times 2, all of a sudden I have...
Yeah, we have to put it on the same axis.
To put on the same axis, that's why, yeah. You're right.
You see the double the axis.
Double the axis, yeah, exactly. Okay, well, I'm going to do it the other way. So let's just change the color so that it, first of all, looks different. So you see, actually it became a little bit more purple. Let me take a break and talk to you first about time series and job values. Time series is exactly that. A temperature has a point per time. So this at the beginning of the cycle, the temperature was 21. In the middle, it was at 500 something, and here it was at 100 something. So it's a variable. A job value is an instance. There's just one. In this one job, I used 2 meters cubed of ammonia. In this one job, my maximum temperature reached was 550 degrees C. So that is one value. Now, that basically explains this. I'm looking for now flow. So this is like a mass flow controller, dare I say, for water. So let's just make this test. I have here a liters per minute, or I have a gallons per minute, right? I take a gallons per minute, and I have now this device here is temperature. You and I know that, but I'm going to make a small, very simple formula. If that temperature is greater than 150 degrees C, then it's 1.1 gallons per minute, else 0, close. So now take a look at my chart. Now I have my original orangey red temperature, and I have this blue 0, 1.1. Where's my point? There's 1.1, all the way to 1.1, all the way to 0, all the way to the end. So I have now created a virtual signal, a time series, which has a value of 0 or 1.1 as a function of main temperature. So any moment in time, I'll tell you the flow was 0 or the flow was 1.1. Of course, it's fictitious, and this 1 gallon per minute is a round number based on experience. Now, if I want to know, okay, and if I stop here, because I'm mapping, I didn't do it here, but if I map this fake sensor to a meaning called water flow, then automatically QMULUS will totalize this, and you'll see it in that report that I showed you before. If I actually make this to user 002, then it will tabulate it as 002. But now, let me show you if I want to take advantage of all these formulas that I have here. I have a ton of formulas that I could use to my disposal. So if I now tell it to go and integrate this signal here, which is gallons per minute, divide by minute, I now have integrated.
Oh no, you have to write. No, this was correct.
Oh, it was fine. Minute. It's not min, it's minute.
Yes.
Minute, yes. Or divide by 60.
You can also say 60, also fine.
I could have said 60, yes, but it just has more meaning. So I used here 1,000 gallons, okay, in this cycle. That's basically what I'm saying. And because I integrated this flow of 1.1 or 0 over the entire how many hours, and gave it to put it into a value, which is gallons. So I have used 1,100 gallons. I should change my units now. If I integrate, it's not gallons per minute, it's gallons. Having said that.
And you would need to change that to job feature.
And I would change that to a job value instead of, yes.
Yes, okay.
So basically, if I cancel this and we go and we take a look at flow, this is the real signal. that we used and I edited. So this is the real signal that I had created. I gave it its gallons per minute. I gave it its meaning here, right? So this is where I linked it to water. And now all of a sudden I have my blue line, which is my 1.1 gallon per minute. I have my 150 degrees, and automatically QMULUS will take this value and backfill all the data for past jobs. So in its past time, QMULUS, while it's not busy, it will be calculating every single job, checking if temperature is greater than 150, then equals 1.1. Once it finishes all that, it totalizes all that, and poof, it starts populating this quarter, last year.
In fact, the time series is always calculated in time. So if you open a new time series or something somewhere, it's just directly calculated because it's just the execution of the formula. The thing which Frank is right, the consumption is calculated backwards because consumption is just for a particular time frame, and this is there might be multiple hundreds of jobs to be calculated. That's why it takes a bit of time. So it will roughly take 15 minutes to 30 minutes to show up in the chart, in the history and trends, for example, or in the production statistics. That's why we created it beforehand, to be ready to show it to you. Yeah, sorry for correcting you here.
It's very good. Very good.
Okay.
Good.
So then probably we can move further. I will take over again and summarize, or do you want to say something about that a little bit more, Frank?
No, no.
I think we are
It's
good
just
here.
very powerful tool, right? The number of mathematical operations that we have is really your imagination.
Exactly, and you can create whatever signal you like in the end. So if there's something missing and you have an idea to how to model it, you can just do that. It's as well with empirical formulas, for example. If you have an idea how to calculate a good estimate, for example, for the hardness of a piece, you can just integrate, or not integrate, you can just enter the formula and calculate it on the fly, and you can also then draw it as a line in your chart, for example.
Perfect. Thanks. So to summarize a little bit up what we have done today, which apps do we had a look at? Firstly, we had a look at order and quality to check our results from the parts that we wanted to check. Then we had history and trends to see the quality statistics over different jobs that we have done to see if they are pretty much the same or if we have some outliers. Then we had a look at the production logs to investigate the process, which we have seen that the process we were looking at in the beginning had some kind of bumps. And lastly, we had a look at alarm statistics to see if we have some issues with the machinery or the control system, to see if we can see an issue there for the process that we had, or maybe also for the future. Then with our second case study, Frank showed us quite a few things about the production statistics and how to analyze consumptions and create a soft sensor, also called lambda signal, to have a sensor which we actually don't have at our furnace. Now we will have our Q&A with a couple of questions which came from you, which I will ask the guys to answer. And for one, we have, could you provide an example of how a customer has used QMULUS to address specific production challenges or optimize the process? Mike, do you want to?
Okay, Mike, me?
Yeah, just go ahead, Frank. I was just thinking about a good example. If you have something in mind, just go ahead.
Well, I don't know. I think here it's more of a finance question. So if I use a certain recipe, uses more gas, okay, i.e., let's say ammonia for a nitriter. If I'm using more gas, I want to know it, so that, for example, in the quoting process, I need to quote a job. I get this part and it's similar to the other part. I know I could mix it with those parts. Or if I need to treat them separately, fine, but I know that the cycle will be very similar to that. Well, how much does that recipe cost me? And then I could judge and quote this job. So let's say furnace hours is a round number, but now I could really drive down. Like I showed you before, I see this recipe uses this amount of gas per job versus another recipe. So you could really analyze and compare cost consumptions per recipe.
Okay.
So I think that's the ideal.
Thanks, Frank. And then might be another question here. Let's take that one. You showed that we have different how do I read it? Different units, and how does QMULUS work with the different units in charts and production statistics?
I think that refers back to the unit systems. Yeah, we have seen, for example, gallons on the one dialog. We have seen cubic meters in the production statistics, for example. So I hope that is the right background of this question. So what is QMULUS doing? QMULUS is just storing the data as the data has been gathered. So if you gather your information and collect the information, the data in gallons, it will be stored in gallons, but it will also respect all these units. So for example, if you would like to use this signal, going with gallons per minute, for example, as we have used it today, and you would like to do statistics and the overall result should be in cubic meters, all the recalculation and conversion is done automatically in QMULUS. You don't have to take care of it. And other way around, the same manner. So you can just decide what you would like to see in the end. Yeah, so that's the story behind it. So QMULUS is respecting the units of the original signal, no matter if it's a original, a raw signal, whatever, or a soft sensor, as we have it seen in the lambda function.
Perfect. Thank you, Mike. Maybe a last question. How does QMULUS leverage historical data to make actionable predictions and improve process outcomes?
Yeah, this is a good question. I think this is always, this is maybe also a good last question because this is already closing the loop for the next webinar topics. Not the next one, but the last one. So in being in September, or planned for to be in September. We will talk
February.
Yeah, sorry, my bad. February, exactly. So it will be in February, mid of February. Then we will talk about model builder, anomaly detection, and also about for example, recommended actions. So the whole system is doing that by itself. So it's analyzing the data on the fly when the data comes in, checking if there's some abnormal behavior, as we did today by hand, and automatically creating a notification for it, and also giving an advice what to do next, what to do, what are the best ways out. So that is the overall story, I would say. Yeah. Anything to add, Frank?
No, you said it well.
I guess not, but yeah, I hope it could be understood.
Okay, so then we are already at the end of our webinar for today. Thank you all for attending. Please keep in mind, end of January, there will be our next webinar, asset and process management. Yeah, happy that you were all here, and wish you a nice Christmas time. Anything else from you to add, Frank, Mike?
Thank you for joining us. Happy holidays.
Yeah, thanks for joining. I hope you enjoyed what you have seen. There are endless possibilities and options with QMULUS. Yeah, we hope that you would like to learn more. See you in January.
Until January.